So you want to build something, some custom piece of hardware, but you immediately hit this wall of choices, right? Arduino, Raspberry Pi, ESP32, it's a lot. It can be super overwhelming. But today, we're going to cut through all that noise and make sense of this entire world.
It's a classic problem, isn't it? You have this brilliant idea, but picking the wrong tool at the start can just completely derail you. You end up spending weeks fighting the hardware instead of building your project. But here's the secret. The key to choosing the right board is realizing that they all basically live in just two different universes.
Okay, this right here is the single most important thing you need to understand. On one side, you have microcontrollers. Think of them as specialists. They do one thing, they do it over and over again, and they do it with perfect timing. On the other side, you have single-board computers, or SBCs. These are the generalists. They're basically tiny computers that can juggle a bunch of different tasks, kind of like your laptop. Once you get this divide, everything else just clicks into place.
So let's start in that first universe, the world of microcontrollers. This is pretty much where every hardware journey begins, and it starts with the undisputed king of getting started.
Meet the Arduino Uno. Now, you look at those specs today and you might kind of chuckle. 2 kilobytes of RAM, but that's not the point. The point is that its code runs bare metal. There's no operating system, no background processes getting in the way. And that gives it a superpower. Perfect, predictable, deterministic control. When you tell it to do something, it does it exactly when you tell it to, with clockwork precision. It's the ultimate hello world for controlling the physical world. The Arduino is fantastic, but it's also a little bit of an island. It doesn't have any way to talk to the internet built in. So what happens when your project needs to be smart? What if it needs to pull data from an API or send you a notification on your phone? Well, for that, you need to level up. And would you look at the scale of that upgrade? The ESP32 isn't just a little bit faster. We're talking about a quantum leap here. It's 15 times faster. But the real game changer is that connectivity. It has Wi-Fi and Bluetooth baked right in. This thing was born to be on the internet.
This quote really just says it all, doesn't it? If you're building a smart home sensor, a weather station, literally any Internet of Things project, the ESP32 is pretty much the default choice. It's just the most powerful, cost-effective, connected little board you can get your hands on.
All right, so we've learned the basics with the Arduino, we've gotten our project online with the ESP32, but what if you're not just building a fun one-off project for yourself? What if you're building a real commercial product that has to be bulletproof? You're going to need a different class of tool.
And that tool is the STM32. Now, it's not just one board, it's a huge family of chips, and this quote perfectly captures its place in the world. This is what you use when you're ready to go pro.
So why do the pros choose the STM32? It really comes down to one thing: industrial-grade reliability. These chips are built for insane microsecond-level precision. That's why you'll find them inside things like commercial drones, medical devices, and factory robots. But here's the trade-off. It is way more complex. The STM32 does not hold your hand, but that raw control is exactly what you need to build a product that just works. Every single time, no matter what.
All right, so that's the universe of microcontrollers. Now I want you to take a deep breath, because we're about to take a giant leap across that dividing line into the second universe, single-board computers. And the difference in scale here is, well, it's just staggering. Just let that number sink in for a second. 15,000 times. We're not talking about a small step up anymore. We're in a completely different league of power now. And the board that represents this league is, of course, the Raspberry Pi.
And this massive memory gap, it explains everything. With up to 8 gigabytes of RAM, a Raspberry Pi can run a full-blown Linux operating system. That means it can do things a microcontroller could only dream of, like hosting a website, running a database, or even being a full-on desktop computer.
So here's the best way to think about it. The Raspberry Pi's biggest weakness is actually the microcontroller's greatest strength, that precise real-time control. But the Pi's strength is software. If your project involves complex applications, heavy data processing, or serving up a web page, the Pi's your champion. It's a tiny, hackable computer that just happens to have pins.
The Pi is a fantastic general-purpose computer, for sure. But a lot of modern projects, they involve a very specific and very demanding task: artificial intelligence, especially computer vision. And for that, you need some specialized muscle.
And that's where the NVIDIA Jetson Nano comes in. And seriously, that statement is not an exaggeration. This board was designed from the ground up for one primary reason: to run neural networks right there on the device, no cloud connection needed.
Its whole reason for being is that powerful 128-core GPU. A Raspberry Pi really struggles with heavy AI tasks. The Jetson Nano, it eats them for breakfast. It can do real-time object detection, facial recognition, all locally. So the rule is simple. If your project involves a camera and a brain, this is the board you need.
Okay, we've covered the big players. But the dev board world is filled with these really fascinating, innovative boards that were designed to solve very specific problems for very specific people. Let's check out a few of them. Hey, remember that big divide we talked about? Computers on one side, microcontrollers on the other? Well, the BeagleBone Black just smashes right through that wall. It runs a full Linux OS, just like a Pi, but it also has these two special coprocessors that act like dedicated microcontrollers. This gives you that nanosecond-level timing. It's the perfect hybrid for something like robotics or a CNC machine, where you need high-level smarts and super precise hardware control. What if you're a web developer? You want to try hardware, but you really don't want to learn C++. The Tesla 2 was made for you. It literally runs Node.js directly on the board, so you can control motors and read sensors using the language and the tools, like NPM, that you already know and love. It's a cool idea, right? The best board is the one that speaks your language.
And finally, let's talk about actually shipping a real product to customers. This is where the particle photon absolutely shines. It's less about the raw specs on the board itself and more about the entire platform that comes with it.
See, when you buy a particle board, you're getting a whole ecosystem right out of the box. You get a cloud platform, you get fleet management for all your devices, and you get over-the-air software updates. So if you're a startup trying to ship hundreds of these things, Particle handles all that complex, messy back-end stuff for you. It literally saves you months of engineering work. It's built for scale.
So, after all that, what's the verdict? What's the final takeaway? It's simple, really. The best board isn't the one with the biggest numbers. It's the one that is perfectly suited for the problem you were trying to solve.
And this right here, this is your cheat sheet. This is the roadmap. If you're just learning the ropes, grab an Arduino. If you're building a smart plug for your house, use an ESP32. Building a commercial drone? You need an STM32. A tiny little web server? Raspberry Pi all the way. An AI-powered camera? Jetson Nano. Each one has its job. The whole key is just matching your project's needs to the board's superpowers.
So we've laid out the map, you've met all the key players. The choice is no longer this confusing mystery, it's a strategic decision. So the only real question left is, now that you know how to find the right tool, what are you going to build?